Welcome to this quite exciting, I think, unboxing or reveal of the parts for the MAXI CNC Router, which is going to be a substantial size. Now again, like the MIDI, the build of this CNC Router is modular, and the plans and parts list of everything I use will be on my Patron pages. I've decided to design and build my version of a MAXI CNC Router as a 4 foot in the X by 5 foot in the Y. Roughly that is 1500 millimeters long and 1200 millimeters wide. Now I have ordered and received all the major parts here, and along the way I've actually picked up a new sponsor, which is Stepperonline. So we'll start with the stepper motors, the drivers and the power supplies, which are in here. So we'll start with this one. They sent me a couple of promotional cards for Stepperonline. Nice little touch. I shall put them up in the workshop somewhere. And okay, a driver manual. Oh, and that's just the bill head as well. So they've always, Stepperonline has always been, you know, very well packed, very well presented, and I've never really had any trouble at all with all the stepper motors and that I've bought from them. I suppose I'm a fairly regular customer. So we'll start with one of the power supplies. This is a very high power output, high voltage. Pretty standard power supply. This operates on 115 or 230. Of course, in Australia it's 230, and it's the it's a 400 watt, 48 volt, and I've got two of these powering 4 high torque, high power output NEMA 24s. They're a bit special because they I'm not sure, it's 566 or 599 inches, which is 4 newtons. So there's the two power supplies, and we have 4 high voltage drivers. I haven't had these out yet. Normal standard drivers. They're an aluminium. The main body is aluminium with a plastic cover in here. And these again, these will work up to about 60 volts, I think. But we only want them for 48. And they will do, let me see, 4.2 amps, which is the maximum that the motors will take. I think they're actually 4.1 amps maximum, but we will never ever run it at that. So that's 4 drivers. I like to put everything back in the boxes. Oh, they're very weighty as well for what they are. Look at that. Now the big difference with these, now you probably get away with NEMA 23s. But I wanted something with a bit more grunt to accelerate the gantry mainly, because by the time I finish building the gantry, it's going to be somewhere in the region of 70 kilos, somewhere around that. And you know, I'm running 2 screws with it in the Y with 2 of these motors, and you want to be able to move the gantry quick. You want to accelerate fairly quick, change direction, and of course the same with the X, but not so much weight to move with the X, because it's just the motor itself, which is over the back there, and you know, the Z axis itself. But with these, although it says 5 amp, 5 amp and 3.5 newton meters. That is at 36 volts. I'm going to be running these, and it is possible to do so. This is essentially a DC motor, and you can run it above the specified voltage. Hence I'm running it at 48 volts, and it's going to produce about 4 newton meters peak. You know, you don't run it at that all the time. It's just at the very peak load times. And because this is around about, you know, sort of nearly 600 inches, I've got these really, really big shafts to deal with the torque. Okay, now these are 10mm shafts. Okay, and of course the bodily, these are, I think, 3mm in each direction, larger than the NEMA 23s. Which it allows you to get the extra torque as well. Plus these are quite long. They're like 110 millimeters. The body's 110 millimeters long. So you have extra windings in there, extra size windings and outer body. So I've got 4 of those. Here's the rest of them in here. They're very nice, very nice, very even. This is what I like about Stepperonline. Not only are they very good with their deliveries, now, you know, I mean, look at the quality. Even just down to the paintwork and the machining. It is top quality, what you'd expect from a Japanese manufacturer, not a Chinese one. But, and let's face it, a lot of Japanese and South Korean companies, although they say, oh, it's, you know, South Korean product or Japanese product, it's actually made in China. But this is top quality stuff. That's why I use them. So that's it for the stepper motors, drivers and power supplies. So now we'll move on to, I think, the spindle, because that's something really special as well. Okay, the spindle. This one is really special as well. I mean, over the years, you know, I've done a lot of research in what's the best stuff to buy. and why. This is a combination set that I purchased, and I'll show you now in a second, as soon as I can get this out. This again is extremely well packed. Oh, now this is really, really sweet. Let's give ourselves a bit more room here. This is a professional 2.2 kilowatt, which is 3 horsepower spindle, and it's really solid. It's as much as I can lift with my one hand, actually. Well, yeah, once you've got a good grip of it, it's okay. So you notice that the body of this and the big thick backing moulded, I suppose, chassis, alright, that's what the mounting holes are, okay, and it's an air-cooled model, but it's very weighty for what it is, I can tell you. ER20 call it. That's the only way to go. You know, if you go 1.5 kilowatt, which is 2 horsepower, you only get a I think the largest you can get is ER16, and of course the largest tool you can get in that I think is 10mm shank, something like that. But this one, you go all the way up to 1/2 inch shank. And of course this particular air-cooled model is equipped with 4 ceramic bearings. Normally they're hardened steel ball bearings. The maximum RPM on those will only be 18,000 RPM. Well, it's not really any good for me because I use quite small ball mills, and you know, you have to spin them right up. 24,000 RPM, 22 to 24,000 RPM. So I bought this one equipped with ceramic bearings, which allows you to go to 24,000 RPM, which is stated on here. And unfortunately this particular model is 220 volt only. They don't make 110 volt, but I do understand that most households in North America now, we're just talking about North America here, and possibly South America, do have the facility to have a 220 or 230 volt power socket put into, you know, your workshop. It's available there off the grid for you. Okay, so you'd have to talk to your local electrical supply mob. So they've sent a couple of collets as well, an 8mm and a 8mm and a 9mm collet, which is nice because normally they don't send collets at all, these people. But this supplier and manufacturer, I got this from the manufacturer. Okay, very good. Again, absolute top quality stuff. It's all balanced. You can tell it's been balanced. If you look at the nut on the ER20 collet, you can see little drill marks here where they've had a sensor on here to sense vibration. Alright, they probably put 2 or 3 sensors on it. Spin it up, and those sensors will even tell what part of the what position the rotor's in, where the most weight is. So they machine a little bit out. It's like balancing a wheel of a car, and a little bit and a little bit until they get it perfectly balanced true. And of course they have to do that on the collar nut, because the nut itself might be out of balance. So they balance it all as a whole. So that's why you see these drillings on good CNC Router motors, or I think professionals like to call them spindles. So this is a CNC Router spindle. So there's that. Now I did buy this as a kit then. Again, very well packed. I did open all these actually, because I would hate to unbox something and it be, you know, a load of rubbish. Okay. Operator's manual in probably, how many different languages are there? 1, English, which is good. So we have the operator's manual, so we'll know how to set this up. Ooh, look at that. Oh, that's nice and compact. It's even got its own cooling fan inside. Look at that. Very compact unit, metal, on a metal chassis, aluminium. Very nice. 220 volt Lathe amp, 3 horsepower driver. Very nice little unit that. That's going to be a lot of fun. Okay, so there's that. Now this one was quite a surprise to me. And of course this is my gantry material. It's, if I can bring it up, it's quite a weight for aluminium. This is 160 by 80, and this is professional gantry material. The type that you would see on an Avid CNC, something like that, and many other suppliers too. And very nice, 1200 long. Now, what the surprising thing about this was, I saved $100 by importing this direct from China, because the supplier in Australia, where I live, wanted an additional $100 plus freight into Tasmania. So it's going to cost me nearly $180 more than what I actually bought it for. It's ridiculous. I think people are getting ripped off left, right and centre. So anyway, there's the gantry, and we're a little way off putting that together too, which I'm going to enjoy a lot. I've got some plate aluminium that I won't actually show you now, to, you know, make side plates out of. And incidentally, that gantry material is about 14.5 kilos. It surprised me. It's quite hefty, actually. I'm glad they didn't make it of steel. Okay. Next thing. What do we got in here? Oh. Okay. We'll open this up. We've got an interesting way of packing these, actually. So this is the coupler Actually, it's two couplers. One coupler is inside the other. Okay, so that's the coupler for the stepper motor, which I'm going to have to bore out, I think. It's okay. It's set okay for the stepper motor, but this end is going to have to be bored out. That's no problem at all. And of course, this is to accept the ball nut. And now I used to make my own, but believe it or not, these were free because I bought a set from the same supplier, and so it works out that you get these free, which I'm very happy about. So that's those. I'll leave these here like this. Now then, what else have we got? Oh, bearing blocks. Again, all tied up nicely. I'll just undo one actually. I'll undo the double one. Okay. Double bearing inside there. Nice, very nicely machined. I use these smaller ones than these for the MIDI. And of course you get the lock-in nut for the end as well. And these are angular contact bearings. Okay. And look how they supply these. It's the first supplier I've had that supplies, you know, in a box and then a plastic tube, so they don't get damaged or bent. As you can tell, I haven't opened this yet. Extremely well packed. Oh, look at that. Oh, very nice. Of course, these are 1605s. Much bigger than the MIDI. Even come with a grease nipple. Look at that. Beautiful. Oh, lovely. Even down to the thread. Look, perfect. Very, very good quality stuff. And of course, you know, this is 400 mil action, and so that, you know, that means I'm going to have nearly 350 millimeter of Z action. Call it 300 maybe. You never get the full travel because you've got to take up the distance of this. You've got to subtract that away, and of course the mechanism that holds the Z-axes on the rails themselves. So I'm sort of looking. I'm looking at. I was looking for about 200, so I thought I'd give myself a little extra. So I might get 250, possibly a little bit more, but I'm not totally worried about getting any more than that. So we'll put that away, and we'll see what else is here. Oh, look. I won't actually undo these And I certainly won't undo these because I don't want ball bearings all over the floor. Now, these are square linear rails, 400 millimeters long. And of course these are the square linear rail carriages. Okay. Inside there's like plastic, a plastic tongue, as it were, that keeps the balls in place. So when you slide it on the rail, you know, the plastic will slide out. Then, you know, you're not going to lose ball bearings all over the floor. So you do have to be a little careful with these. But these are the best means of rails to go with. I mean, on the last build I used linear, full supported linear round rails, which are good. These are better. Okay. You know, you can put these under a lot more, I suppose, load, as it were. You know, I mean, if you wanted to build a full-on milling machine, you know, for hard steel, metal, this is what you'd be using. I mean, this is what MAXI use, and you know, all the professional machines. So I've got these in, this is for the Z axis, so this is 400 millimeters. I've also got 1500 millimeters. Now I bought for all the axes 1500. With the X axis I'm going to have to shorten it up, but you know, I can do that. That's no great hassle for me. And the reason I bought them all 1500 long is because that's about as long as you can get them delivered. And if I'd ordered 1200, it would have cost me $25–30 more, because they charge cutting fee, as I understand it. So you know, I saved $35–40 by buying 3 at 1500 long. But you know, that's entirely up to you what you want to do. So really, I mean, I don't know whether you want me to. I don't think it's worth unboxing these, because they're just longer ones of these. You know, they're identical. These are 20 millimeter. Okay, they're classed as 20 millimeter linear square rails. Hardened steel, doesn't flex, doesn't bend, and we're going to make a substantial CNC router, which I'm dubbing the MAXI CNC router. Okay, like I was saying earlier, this MAXI CNC router build, I'm designing my particular model at 1500 or 5 feet long in the Y, and 1204 feet in width. But really, you know, you can sort of build it any size you want. You know, that big and smaller, you know. I wouldn't advise going ball screw any longer than 1500. It starts to get a bit silly after that, you know, a bit too long. You know, you wouldn't have a, you know, sort of a 3 meter long screw. If you did, you'd have to go up to, you know, sort of 25 millimeter to an inch. It starts getting real expensive. And if you wanted to build a full-size version of this, you would go rack and pinion. And I personally, I don't like rack and pinion myself, but many others do. So yeah, 1500 long, 5 foot long, is about the longest screw that you would go with, I think. So how I'm going to do this build, I've decided that the top chassis or superstructure that all this is going to be connected to, apart from the gantry, is I'm going to have steel box section. So all the upper part is all going to be steel box section welded, and I'll be showing you. Quite a few people have asked me when I first announced this. I think I announced this to patrons and maybe subscribers as well, about that I was going to, sort of have a welded chassis, and I had quite a few emails asking if it was possible I could put out a couple of videos, basic videos on how to weld. Well, yes, of course, I will do that. I mean, I've got welding equipment here. I've got stick welding and I've got MIG welding, and yes, I can show you how to do that. And it'll probably be one of my next videos. I'll probably do a couple of videos because regular viewers of my channel will know I try and show you in great detail, so you don't make mistakes. And if I make a mistake on whatever I'm doing, I'll show you it, so possibly you don't make a mistake. So yeah, I'll be showing you a couple of videos on welding. It's not as straightforward as what other people make it look. It's quite, it can be quite complex, but I'll make it as easy as I can. So it's going to be in two sections. I'm going to build it. I'm going to make the top section, which is going to be the main Y superstructure, then which the Y linear rails are going to be mounted on top, and the bull screws on the side, and of course the bracing between it's all going to be fully welded, but the lower section, there's no real need to have it made of steel. I could do, but if I've got quite a lot of I think it's 100 by 100 square, big heavy stuff. I'm thinking, I might make the lower section, the legs and supporting chassis, then up off the ground, like I made this bench in a very similar manner. It's ultra strong. I mean, it's got a ton of wood inside it, and it's still perfectly flat and straight and true, and I'm not worried about that anyway, because the straightness and flatness is all taken care of by the welded chassis or superstructure up on top. So really all I'm doing is just supporting the the machine on wood legs, and be on wheels as well, locking wheels, and I think that would be okay. And as cost effectiveness, wood is a hell of a lot cheaper than what steel box section is, because I'll be using I think 3 or 4 millimeter thick box section, which is going to be like 90 by 90, something like that, wherever I can locally get. And then again, it depends on the meterage, how much per meter. Ultimately, the cost is going to be the deciding factor. But like I say, I've got a lot. You might be able to pick it up on the camera. There's one stood up over there that's 3 meters long. That's 100 by 100 square. I've got a couple of those actually. So I mean, I've got material here that'll do it. There's more than man enough to do it. So why wouldn't I use it? Sort of thing. Again, this build will probably be 15, 18, 20 videos, because I'll be showing you every single stage of it, what I'm building, what I'm making, how I'm making it, and why I'm making it, how I am. And you know, the making process as well, putting it together, so you don't have to figure it all out. You know, if you want to copy what I'm doing, that's what it's for. So controller. I did put, a month or so ago, I put a video out saying, what controller would you like? Would you like Mach 3, Mach 4 or an SMC? Well, quite a shock actually. Not many people wanted Mach 4. I'm not really sure why, but it's like only about 20% people wanted Mach 4, and then it was pretty well an even split between Mach 3 and an SMC controller. So what I thought I would do with this build, because I've got spare boards here, you know, breakout boards, actually smooth steppers, I'm going to build it now. I'll build it on Mach 3 first and run it. Then, you know, I've got an SMC controller here, so, or I might even get another one. I'll put the SMC controller on it and do a few months with that. So, you know, so I might do 3 or 4 months with the Mach 3, and then 3 or 4 months with the SMC controller. Then we'll see how it goes and see what responses I get in the comment section, because it's the comment section that really runs this channel. I'll show you what you want to see. And it, you know, if I get enough people saying to me, "Oh yeah, go Mach 4. We want to see how, you know, whatever, how Mach 4 works." It's pretty the same as Mach 3, but a different screen. I'll do it. No problem at all. But like I say, start with Mach 3, then I'll go on to the SMC. All right. So I think I've chatted enough, and I hope you'll join me for this build. And of course, like I was saying, the first couple of videos are going to be just basic welding tutorials. I'll do stick and MIG. I use gasless MIG wire now because there's, you know, the MIG gas bottles, they're so expensive to have at your home. It works out to be like something nearly $300 for a bottle. You know, I mean, you can buy large aerosol can size ones like this, you know, that last you about 5 minutes. It's just not cost effective, so I use what they call flux core wire. And I'll show you all about this and how to use it if you want to go MIG. MIG's a little bit more expensive, but I find it very easy to use a MIG. I used one for many, many years. Okay, so that'll be it for this video, and I hope you join me for the start of this build on the MAXI full-size CNC router. So if you've liked this video, please like and subscribe, and don't forget all the parts and the drawing information will At the moment, all the parts information is available on Patron already, and specifications. But the drawings for this build won't be there until I'm well into the build. All right, but they will be there as soon as I can get it done. So, if you'd like to become a patron, the information will be in the description area underneath this video, and it's the patrons, that run, that allow me to do things like this. So, thank you for joining me, and I hope you pop back in to see one of my other videos, and also further videos on the build of the full-size MAXI CNC Router. So, bye for now.